everybody solving paper 2 version 1 May June 24. Which are quantities correctly categorized into scalar quantities and vector quantities? Scalar mass, energy, vector weight, and acceleration is correct. Which name is given to quantity of matter and object? Mass. Body is moved from X to Y, where G is different. What happens to mass and weight? Mass stays the same while weight changes. Weight equal mass times G. Mass of object and volume. What is density? So it is 2.5 times 10 to power 3, because I wanted to transfer it to gram, because all options are given in gram, over 480. The answer would be 5.2 gram per centimeter cube. Which object is in equilibrium? I will choose A. B will be a rotation, and certainly not C or D. Ball of mass M vertically hit hard surface. Speed of heading is given. It rebounds vertically upward, so it falls downward and rebounds upward. If velocity downward is positive, upward would be negative, and the change in momentum will be mass times minus V2 minus V1. It's not given in the option, so we can make the downward negative and the upward is the opposite, so positive, and change in momentum would be mv2 minus v1, which is positive. Stone dropped from tower, 50 meter, mass of stone, and speed is needed. We know that all of kinetic energy of stone is gained from the conversion of gravitational potential energy, and the gravitational potential energy is mgh, so it is 3 times 10 times 50 joule, and this quantity will be equal to, let me write it here, kinetic energy, or equal to half mv squared, so v squared equal to 2 over 3 times, or v equals the square root of all of this. On your calculator you would find that it is 31. Yes. Coal-fired power station generates electricity. Coal is burned. Energy is used to boil water. Steam from water moves generator that produce electricity. What name of energy stored in coal and in moving generator? In coal, chemical; moving generator, kinetic. Ice in glass of water in warm day. Short time later, ice disappears, water appears outside glass, which two changes taking place. Ice disappears, it will be melting, and water droplets appears, it will be condensation. Certainly condensation of water vapor in air on surface of cold glass as its temperature dropped by the uh, drain of thermal energy in water to melt the ice. Gas of volume inside container, piston pushed, volume decreased, temperature constant. What effect on kinetic energy of gas particle and pressure of particle in the container? So as temperature is constant, we have that B1 V1 equals B2 V2, and as the question asks about the change in pressure, we can write this equation on this form: inverse proportionality. So V2 is 100 and V1 is 200. This ratio is half, which means that B2 equals 2B1. So pressure doubles and kinetic energy remains constant because temperature is constant. Which graph of B and V when mass is fixed, temperature is fixed? Certainly will be the shapes that we used to know. During evaporation, most energetic particles escape, temperature changes, which identifies particles escape and temperature changes. Place from which particles escape is the surface and temperature decreases. With close on a line, evaporation, type of weather, increase evaporation, hot day with wind, solar water heater is designed to absorb energy from sun, which surface texture and color best for the heater. It will be dull to decrease the reflection and black to increase absorption. Which about waves is correct? It transfer energy without matter. You remember that medium particles move around its position, but doesn't don't leave the position, their position. Angle of incidence on a Blair mirror gradually increased to nearest degree. What is maximum possible angle between incident and reflected? So as the maximum possible incident angle is 90 degree, the reflection one is equal, so it is also 90 degree. So angle between incident and reflected ray would be 180, which are necessary to light to totally internally reflected. Incident in less dense medium, yes, and angle of incidence less than critical, no, it must be greater than critical. Remember, here is air, here is glass, so incident angle should be greater than critical to have, sorry, reverse the situation here. Incident angle should be greater than the critical to have not a part refracted and part reflected, to have all of the incident internally reflected inside the glass without no refraction. We need that the incident angle here is greater than C. If it's equal to C, I just remind you, it will be parallel to the surface. Diagram shows ray flight passing from air into transparent substance. What is N? N equals sine I over sine R. So it is sine 40 over sine 30. You will find the answer is B. Ray flight in optical fiber, which explains condition for maximum transmission of light by optical fiber. To have maximum transmission of light, we should have all of the light inside the fiber till the end. So we should have a total internal reflection. Glass must slow down light as little as possible to make critical angle for fiber as large as possible. So we should remember the relations. N is equal 1 over sine C, or sine C equals 1 over N. 1 over N means 1 over C over V, so sine C is equal to V over C. As we reduce V as much as possible, we will find that this whole ratio will be decreased and hence C will be decreased. So regarding the first choice, it says that glass must slow light as little as possible, so V decrease to make critical angle for fiber as large. No, it's not correct. B, V is as little as possible, and C as small as possible. Yes. Which region of electromagnetic spectrum is used to detecting fake banknotes? It is the ultraviolet. Remember the uh, UV scanner where you put the banknote underneath and you can see the mark here, this shiny mark. So sound wave travels at distance between center of compression and center of nearest rarefaction is, what is frequency? We have a speed, frequency, and something to have wavelengths. Should remember the relation. So frequency equal 330 over lambda. Lambda here is double the distance that is described in the question. Compression to rarefaction is half the wavelength, so the total wavelength is double this distance, so it is 5 times 10 to the power minus 2, as we have this velocity in meter per second, so wavelength should be in meter to have frequency in second minus 1 or in hertz. Calculate it and you will find the answer C, which used in medical scanning of soft tissue. It is the ultrasound. Remember, X-ray is used for hard tissue, which is bones, which describes suitable material for temporary and permanent magnets, certainly soft iron and steel. Which point is strongest? It will be A, because lines are closer to each other than the other points. Student determines resistance R, circuits, which one can be used? It is D, because voltmeter is placed at the terminals of resistance, and ampere connected in series. Diode and resistor connected across variable DC supply. Terminal X is initially positive, and at a maximum value, potential difference across X, Y is adjusted, so it changes as shown in the graph, which graph shows how current varies with time. So we have here VT graph for this circuit, and we need to know IT graph. As X is initially positive, we do not expect the current to flow in this circuit because we have here the diode in a reverse biased connection, so it opens the circuit. So during the part where the potential difference across X, Y is positive, which means that X is more positive than Y, we do not expect a current to be corresponding to this part of the graph. So we do not expect this graph, we do not expect this graph, and this, so the true answer is D, because at the first part the current is 0, which is the case here, and at the second part, when the difference between X and Y is negative, which means that the X is negative, so Y is positive, so current can flows, and as the voltage increase in this direction or in the negative direction, we can find the current increase also in the negative direction. Okay. When conductor in circuit cuts magnetic field, current induced, which correct about induced current? Is it in same direction as motion of conductor? Or let us remember first the situation of a coil and a magnet. When the coil moves towards the magnet, it cuts the lines of the magnet, and an induced current will be formed in the coil, such that must form a magnetic field in the coil. I mean, the induced current must form induced current in induced magnetic field in the coil, which opposes the magnetic field here. Okay, such that north pole of the induced we should have north pole here like that. Okay, to make a repulsion, and this repulsion will make the movement of the coil in this direction, so opposes the direction that causes the induced current and the magnetic field formed after Z. Okay, so induce the current in same direction of motion of conductor. This wouldn't be the case. I suppose that this choice might be more clearer if we used a wire, not a coil. But let me read the other options. Induced current is in opposite direction to motion of conductor. Direction of induced current in same direction as magnetic field. Direction of induced current opposes the change causing it. This is correct. Ultimately correct. It is the Lenz's law. Direction of induced current opposes changes that causing it. However, we need to think about a conductor that's not a coil, a wire, in a magnetic field, just to imagine how these three options, uh, how to judge the three options. I have a prejudgment that all of them are not necessarily correct, but I wanted to show you how to think about. Okay, the last option is guaranteed to be correct, and we have Lenz's law, and we have this case of coil moving toward magnet or magnet moving towards the coil, but I need to think with you about the case of wire, regular wire. So here is a magnet, and here is a magnetic field in this direction from left to right, and here is the wire. If we move the wire forward or backward, certainly the current, the induced current, cannot be in the same direction as the motion of the conductor. It must be in a perpendicular direction. So it's not A. Induced current is opposite to motion of conductor is also not correct because it's not in the same or not in the opposite. It is perpendicular. Direction of induced current in same direction as magnetic field also not correct, must be perpendicular in all of these options. Solenoid carrying electric current, which compares the strengths of field at y, z, and x. At y is it equal to x, and at z is it less than x. At y is equal to x, yes, because field lines inside the coil are parallel and there is a uniform distribution of it, so we have the intensity here like here, but as we go outside the coil, we have the lines getting away from each other, and so the strength is reduced. So A is correct. Conducting wire placed between poles, just to we're discussing a case like this. Okay, electric current is shown, force on wire out of page. So here is direction of field, here is direction of current, and here is direction of force. Use your left hand to judge the conditions, the following conditions. Current toward the top and direction of magnet unchanged. So force will be into page. This is correct. Current toward the bottom, that's the case here, and the field is reversed. So let me use my hand, current to bottom and field reversed, so it will make the force into page. So this is also correct. Current, and you can uh, judge while they are correct or not when seeing one of the three is constant and only the second is changed. We have the third to be changed too. Okay, but if two of the three changed, we must have the third as it is. I mean, if we reverse the magnet and reverse the current, use your hand, reverse, we will have the third as it is. But when reversing only one, we should have the third reversed too. Anyway, current in wire alternating, wire vibrates in and out, yes, because force is in and out. So it is all of the three. Which type of electric current in primary and secondary for a transformer? Most of them are alternating, primary alternating to make alternating magnetic field, and secondary reduced alternating current. Scientist fires alpha at thin sheet of gold, which is correct about scattering. Alpha scattered to attracted to nucleus. No, most of them are positively charged, so cannot be attracted. Half of mass of atom is in nucleus, not half. Most of the mass, most of alpha are detected and deflected. No, most are passing in straight line and only very small percent is deflected or largely deflected. So it is D. What is relative charge on golden nucleus? As for proton positive 1, it is positive 79. Isotope of hydrogen has nuclide motion. How many neutrons? And relative charge on nucleus. As this is one proton, so we have one neutron. And as we have one proton, we have positive 1. Source and detector and the different materials between source and detector, and 10 minutes we have in case of no material this count reading. For sheet of paper, for thin sheet of aluminum and thick sheet of lead, what types of radiation is this reading is like that? For sheet of paper, it means that there is no alpha because alpha is stopped by the sheet of paper, and the thin sheet of aluminum reduced the reading, so there is beta, and the lead means the lead case means that there is gamma. Reading on detector placed near radioactive material is background is half-life is what is reading on detector after 68 hours. We should first correct for the background, so 536 minus 44 will gives okay 492 after 34 hours it will be 246 after another 34 hours it will be 123. We should add the background here to find the reading on detector, so it is 123 plus 34 equal 167. Planet in solar system at point in its orbit where it is closest to sun. As it is closest to sun, we should have the speed at maximum and gravitational potential energy at a minimum. Okay, you should remember that in the orbit, sun is here, the closest point, gravitational potential energy is minimum, while kinetic energy or speed is maximum, and as the furthest point, the opposite. Gravitational potential energy is maximum, whereas the kinetic energy is minimum. Okay. What's main process power the sun? It is fusion of hydrogen to helium. Okay. Galaxy is at from Earth at which speed moves away. Should remember Hubble's constant, which has a unit of second minus 1. And it relates velocity and distance, so it is velocity over distance. I remember the law by this way. And as we have the distance and we have the Hubble constant, you should keep it because it is easily to be remembered. Its inverse gives the age of universe, which is 14.4 years. So the velocity of the galaxy will be 1 over 14.4, but as the results here are given in second, we should convert this 14.4 billion years, okay, into second. So I will multiply by 365 days times 24 hours times 3600 to be in second. Okay, And all of this, which is the Hubble, the inverse, the Hubble constant will be multiplied by the distance of galaxy, which is 3 times 10 to the power 20. Use your calculator, you will find the answer is 6600, but you should choose, 660, but you should choose the kilometer per second one, not the 660 meter per second. Should choose the kilometer one, because here we used the value, in kilometer. We haven't converted it to meter. Astronomer observes distant galaxy. Table shows distance and speed of recession. Distance, brightness of supernova in the galaxy, and the speed changes in wavelengths of starlight from galaxy is this is correct. Thank you for watching.